We are with question number 2. Someone told me that my pound sign looked bad in the other question, so I tried to make it different, but I don't think it really looks that much better. In fact, I think it looks worse. So question number 2 is a little bit more complex in my opinion than question number 1. So the first scenario is that there is 30 milliliters of a hydrochloric acid solution which has a molarity of 1.5, and then we add 22 milliliters of sodium hydroxide to neutralize that solution. Then you add another 15 milliliters of sodium hydroxide to that solution, and then we have to solve for the pH of that new solution. So, first of all, you know that when it's neutralized, the pH is 7, and if you add more base to an already neutral solution, we're expecting our pH to be above 7 because we want it to be a basic solution because we're adding more base to a neutral solution. So let's just keep that in mind, and first thing we have to do before we even try and solve for anything, we write out the equation of this. So we have sodium hydroxide plus hydrochloric acid, and that will yield water plus sodium chloride. And before we can solve for moles or anything like that, we have to get the concentration of both. We have the concentration of hydrochloric acid, but we still need to solve for sodium hydroxide. So let's go do that. Over here, we have the Salkson shortcut equation, as I like to call it, and I'm sure many others have. So we have the bases. We can have the left side of the equation represent the base and the right side represent the acid. So we can plug in our volume for the base. We can't plug in the molarity because that's what we're solving for, which is 22 milliliters. Then we know that our hydrochloric acid, has a molarity of 1.5 and its volume is 30 milliliters. So using that, we can now solve for our molarity of our sodium hydroxide, which is 2.045. Now using that, we can solve for moles for both of the reactants. So sodium hydroxide, we know that its molarity is 2.045, and we know that we added 0.037 liters in total. Now keep in mind that the 22 milliliters that I just used in the other equation was purely to solve for the concentration, because we know in total that we added 22 milliliters, then another 15, making it a total of 37 milliliters. Of course, we got to divide by 1,000 to convert to liters, which would give us 0.037 liters. Solve for that, and we have x equals 0.0757. Now, let's do it for hydrochloric acid. 1.5 molarity equals x moles over 0.03 liters. Of course, that's 30 milliliters divided by 1,000 to convert to liters. And x equals 0.045. Now, we can solve for our moles given, our moles that have reacted, and the moles that we have in excess. So our moles given, as just we figured out from the previous two equations, 0.0757 moles for the sodium hydroxide and 0.045 moles for hydrochloric acid. Now we can use all of the moles of the hydrochloric acid because we would like to use as much as we can. And since it's a 1-to-1 ratio, then we use that same amount of 0.045 moles for the sodium hydroxide. That means that we have 0 in excess for hydrochloric acid, making it the limiting reactant. Anybody catch this LR earlier? If so, hats off to you. And here we still have an excess because we have less moles have reacted than the moles we've been given. So we subtract reacted from given, and we get 0.0307 moles in excess. Now we can solve for the concentration of hydroxide right over here. So we know that there are 0.0307 moles of it. That's just the moles excess. And 0.067 liters. That is 67 milliliters. That is the 30 milliliters of the hydrochloric acid and the total 37 milliliters that we added of the sodium hydroxide. So when divided, we can find that our sodium hydroxide concentration is equal to 0.458. And we can sub that into our good old equation over here. The hydroxide concentration times hydrogen ion equals 1 times 10 to the negative 14. We sub in 0.458 for OH, and we can solve for hydrogen ion, and that is equal to 2.18 times 10 to the negative 14. All right, now we can solve for our pH. by plugging in that hydrogen ion concentration into here. There it is. And the negative log of that is 13.66. So, like our prediction earlier, it is a basic solution because we added base to an already neutral solution. So it does match our hypothesis, which was an educated guess. It wasn't just a guess in the dark. But yeah, thank you, and see you soon, I guess. Or maybe not. Who knows? Corona.